Hi, my name is Whitney Jenkins, and I am a product manager at Google working on GKE IPAM, and this is my colleague, Ivy.
Hello everyone, my name is Ivy. I am a software engineer from Google, and then I mainly work on GKE IPAM.
And today we are going to talk about Kubernetes IP management and talk about some of the core concepts and strategic solutions. That's okay. So let's dive into some of the core Kubernetes concepts. So in GKE, we have a flat network that is fully integrated. What this means is that every pod receives a unique routable IP that is part of the VPC's IP range. There is direct native integration with GCP services like load balancing, service mesh, VPC peering, and shared VPC. Pod IP addresses are visible throughout the network, so this is really important for observability. This enhances telemetry and simplifies debugging. Pod IP address ranges can be made accessible for on-prem through GCP tools like Cloud VPN or Cloud Interconnect.
Kubernetes has a flat network model, but Kubernetes itself does not handle this for the implementation details. Instead, it delegates the entire responsibility to a set of plugins. So CNI is a CNCF project that creates a simple pluggable interface between container runtime and the network plugins. So this diagram shows the workflow when a pod is scheduling and when CNI comes into play. So at first, the kubelet will decide to start a pod, then it calls the container runtime to create a pod sandbox. The runtime then will look at the CNI plugins file at -etc-cni-net.d file. It will execute the specific CNI plugins and execute the add command that is defined in the interface. The CNI will do all the work, including create the network interface and assign the IPs or manage the routes. After that, the pod is now live, and then it will be able to communicate. It is on the network. GKE's default networking mode is VPC, and it is standard. The pods will get a real IP address from the secondary ranges from the cloud VPC. GKE is use a standard CNI plugin where it is something called local host that it merely just look at the pre-configured ranges. It assigns the pod IP ranges every time it needs one. But this plugin is able to actually redefine your own logics and, for example, talk to your cloud container, your own cloud APIs to decide which IPs to allocate to the pod. For the DPv2, GKE uses a Cilium or eBPF for its CNI plugin. This is a big deal because it is high performance, it's more secure, it has built-in securities and better observability. But for the IPAM plugin itself, GKE is still using the standard localhost plugins. And I will hand over to Whitney to talk more about cloud networking.
Thanks, Ivy. So with that, we'll go into what do you have to think about when you're configuring a GKE cluster. We'll be focusing on VPC native clusters. There is this concept of a route-based cluster, but that is not something that we are really supporting anymore. So when you're configuring a new GKE cluster, the first thing you have to think of from an IP addressing perspective is what ranges do I need for my pods, nodes, and services? And calculating the size of the range you need can be really complex. The example that I like to walk through is that if you go into our documentation, you're going to see what looks like Calc 3 to figure out what range you need to get started with. The other thing that has traditionally been a complexity with creating a GKE cluster is that you not only have to think about what size range you need for the workloads that you want to run right in this moment, but you also have to factor in future growth for that cluster. And we know that this can be super wasteful, especially for clusters that are created in the IPv4 address space, because that's a very scarce resource. So that planning and calculating upfront is really a crucial task to get right, so that you don't have to do any destructive configurations later on. So when you are creating a GKA cluster, every GKA cluster is created within the box of a VPC. And when you are creating within the box of that VPC, you have to specify a subnet. And that subnet has a stack type. The stack type is really important, and I can go into depth a little bit more on the different stack types that we support. But the reason that it's important is because it determines what type of cluster you're going to create. So if your subnet is an IPv4 subnet, then you're going to be creating an IPv4 cluster. But if you select a subnet that supports both IPv4 and IPv6 addresses, then that's how you're able to create a dual stack cluster. From there, the additional complexity on how you can configure a cluster will relate to how you configure the setting for max pods per node. So the default setting is 110, and what this means is that one node has 110 pods, and it's going to require you to provide a /24 or 256 IPs. So diving a little bit in depth into the stack types. Today, we support IPv4 and dual stack, but I kind of want to get a survey of the room just by hands. How many of you are interested in creating IPv6 clusters? This is awesome. I love to see the hands. So IPv4, just running through at a high level, every range is going to be IPv4, pods, nodes, and services. The one thing I do want to call out is that if you're not aware of it, Google has a reserve /20, so it's 34.118/20, so a little over 4,000 IPs that we reserve for services. So this is something that you don't have to take out of your own VPC network and allocate to the services that you create for your cluster. For the dual stack scenario, this is awesome if you're able to sit within this space today, because it will help enable a seamless transition to IPv6. In this scenario, both pods and nodes are assigned both an IPv4 and an IPv6 address. And then, as Ivy mentioned earlier, this requires that you create the cluster with DPv2 or data plane v2 enabled. In the IPv6 world, the reason many of you may be attracted to this option is that I like to air quote this and say this is almost like infinite IPs, because the address space is just so large. So you don't have to worry about the difficulties of IP planning or really hitting IP exhaustion issues. And what we have here will be pods, nodes, and services with all IPv6 addresses, no IPv4 at all. And then, of course, enabled on our latest and greatest data plane v2. So we talked a lot about the core kind of Kubernetes concepts, but I kind of hinted at a little bit. There are some challenges to running Kubernetes at scale. One, GKE just takes a lot of IP addresses. It can be difficult to manage those IP allocations. So not only with like some of the Calc 3 information that we have like on our doc site making it difficult, IPAM is just difficult in general, and a lot of the times we've heard people use spreadsheets to manage their IP address space, and so it can just be really difficult to get a picture of what's going on, as well as find a free range if you need a free range. There are some IP allocation inefficiencies, and those can lead to IP exhaustion. One of the IP allocation inefficiencies that we hear a lot about is the 2x pod IP requirement aligned to the power of 2. I'm seeing head nods. Very painful. And so that can cause you to use a lot of unnecessary IPv4 addresses. And as I mentioned earlier, that's a really just scarce resource, so we don't want to be wasteful with it. From an observability perspective, it can be hard to figure out what's going on in my cluster and what's going on with my IP address space. So if you do encounter an IP exhausted issue, you're just like, what's going on? Like, how do I solve this? And then we've also heard from many customers, GKE is just missing some features. And one of the biggest features we heard missing is support for pure IPv6. So let's talk about how we can start resolving those challenges. Now, we'll get into IPv6 a little bit later, but everyone isn't ready to move to IPv6. I didn't see every single hand in here go up. So if you are not able to move to IPv6, I still want to be able to meet you where you are and help you navigate the world of IPv4. So let's talk about strategies of how you can do that. The first strategy is I want to make sure you understand all the ranges that are available to you for use with GKE clusters. In addition to the well-known 10/8, there are 2 additional RFC 1918 ranges that you can use with GKE. And together, those 2 ranges give you an additional over 1 million IPs that you can use. These IPs can be used for pods, nodes, and services. In addition, there are a few features that Ivy will be talking about later that will allow you to add additional ranges to existing clusters, with that additional range being one of these to give you more scale. And this is really powerful because previously, if you hit the, I like to call it the dreaded IP space exhausted error, you would have to recreate your cluster and migrate your workloads, which also was really painful. The second strategy is leveraging non-RFC 1918 ranges. So this is 100.64/10, so this is a little over 4 million IPs that are available to you. This range can also be used by pods, nodes, and services. You can also use it with the multi-subnet and multi-pod CIDR feature that Ivy will be talking about later. And then if you have any kind of advanced configurations with load balancing or interested in external or internal destinations, there are ways that you can also leverage this range to make your custom architecture work for you. And then the third one, which I think is kind of one of the most exciting ones to me, is leveraging the Class E address space, so the 240.0/4, which is over 268 million IPs. I will talk about this a little bit later, but we have a really awesome blog post out there that talks about how customers have used Class E to mitigate some of their IPv4 exhaustion issues and buy them some additional time until they're ready for IPv6. You can use the Class E addresses for your pods and services. It can be used on existing and new clusters. And there are ways that you can use the IP masquerading agent to SNAT for your pod to node communication. Now, the thing we hear from a Class E perspective is, I'm not sure if I can use it, it's protected today, but what if it becomes public soon? And so I wanted to just hit on some of the kind of common misconceptions that we hear. I'm sure there may be many based off of your own kind of situation that may be of unique interest to you, but these are the most common ones that we hear. The first one is that Class E addresses do not work with other Google services. This is just not true. Class E can be used with many Google managed services using private connectivity methods. If for some reason you see that that is not the case, or oh, that's not the case for me, please contact me. It's a bug and we need to fix it. The next one is that using Class E addresses limits communication with services outside of Google. This is misleading for 3 reasons. 1, Class E addresses are non-routable and not advertised over the internet or outside of GCP. There is an exception with Microsoft Windows, but many operating systems now support Class E, and you don't have to use that. From an on-prem vendor perspective, Cisco, Juniper, and Arista support routing Class E addresses for private DC use cases. So there are workarounds here. And then the third one is that Class E addresses have performance and scale limitations. That's just not true. It's an IP range, so there aren't going to be any performance impacts. So with that, I'll give it to Ivy so she can talk in more depth about some of the new features that we have released over the course of this year. Go ahead, Ivy.
Thank you, Wendy. So I would like to highlight several IP management area new features that we launched recently. First, GKE has already supported the multi-pod CIDR. So traditionally, we can only have one segment ranges that you can allocate for your pods. But what if that your cluster becomes scaling up and you don't have enough IP ranges, and that makes it really hard to plan ahead. So multi-pod CIDR is that you can add additional pod IP vote ranges to a cluster. You will also hear another name, distinguished CIDRs, is a SIM feature. And the approach is that it uses additional IP ranges to prevent pod IP address to get exhausted. You can use this command here to simply update your cluster to feed in this new IP ranges that is already created beforehand in the same subnet that your cluster lives in. I'm excited to announce the multi-subnet cluster feature that just went GA last month. This is yet another feature that supports the IP exhaustion problems to solve it, but at a node level. In addition, it brings in a new IP for pod ranges under the same subnets that is for the node. MSC offers a new solution for node IP exhaustion by allowing clusters to utilize additional subnets and then expanding the pod IP ranges. Again, you use the cluster update operation to add additional IP ranges and subnets into the cluster. And we also support the most common load balancers in the GKE world for the multi-subnet cluster feature, including the L4, L7 NAC-based load balancers and L7 gateways. And this is the blog post screenshot that I included. We published recently. I also added a link here about this feature. Next, Kubernetes already supports multi-service CIDR that allows a Kubernetes cluster to utilize multiple ranges for your services. This feature already goes GA at the Kubernetes side, so you can directly use it for GKE version on or after 1.33. But before that, it is a better feature, so you have to enable better APIs in GKE to use that. I would note that there is a limitation at GKE where right now if you use multi-service CIDRs, only the range 34.118.24 is allowed because there are some validations, so we need to make sure it does not overlap with existing IP ranges. We're considering to lift this limitation. It's on our roadmap. Last but not least, I'm glad to introduce the auto IPAM feature. With auto IPAM, we are fundamentally actually changing how clusters are consuming the network resources. Instead of upfront allocation to specify all of the IP addresses for your node and pod in advance, auto IPAM allows the clusters to forget about those ranges, and then GKE will automatically allocate, provision the subnets and the pod ranges for you. It will start from the smaller ranges that sometimes is not possible to manually manage. And then it grows to larger spaces. This is useful when your cluster approaches IP limits, and whether for the pods or nodes, GKE automatically provision those for you. This is a big milestone towards improving the IP management experience, really different than the traditional ones we have. And I hope you will enjoy this feature. We talked multiple features around this GKE IPAM area about the solutions and what does it look like all come together. This diagram has a nice view of it. So we talked about multi-subnets, multi-pod CIDRs, and expanded service ranges with the flexible service IPs. The auto IPAM is really eliminate the toil of IP management and find free ranges for you, for the customers, that they can easily scale up the cluster. We're also working on extending the auto IPAM to multi-networking so that it can help customers to use multi-networking and to run the GPU or TPU workloads on their AI ML use cases. And I will hand over to Whitney to talk about troubleshooting.
Thanks, Avi. So we talked about earlier some of the issues around observability, and so I want to talk about some of the features that we have released to help you get a better insight into what's going on with your clusters. So the first one that I want to make sure you're aware of is that GKE IP Masquerading Analyzer has been integrated into Network Intelligence Center. What this will allow you to do is you can independently diagnose your cluster's egress connectivity problems caused by network misconfigurations. Some of the common reasons that could lead to issues is around the necessary pod IP address ranges are not correctly specified in the non-masquerade CIDRs field of the IP mask agent config map while the SNAT is enabled. And such misconfigurations will lead to those failures, for instance, masqueraded traffic from a pod. So this is available within Network Intelligence Center, and one of the things we have coming soon is connectivity tests to help you also diagnose. From a UI UX improved observability perspective, let's see if I can actually, it's not gonna play it, that's okay. Maybe it's because it's not in the Wi-Fi, but I'll speak to it. If you go into your console and you look at the cluster view and you pull up a particular cluster, one of the things we heard is that from an observability perspective, I don't want to navigate away from that experience. Network Intelligence Center is great, but I want to remain in place. And so one of the things we've done is we have brought that observability in line within your console. So you can see the observability for each of those ranges, so you can see what your utilization percentage is. And then in the top right-hand corner, we have recommendations on what you can do to resolve it. So this is designed to help cut down on some of the toil related with resolving an issue once you have detected it. I can just show this as one of the other screens. But what we will say is like, hey, you can use some of the features that Ivy mentioned, so you can, if this is related to pod IP exhaustion or node IP exhaustion, use one of the multi-pod CIDR or multi-subnet cluster features to add an additional range. And if you need an additional range, hey, maybe you want to leverage Class E to give you enough IPs there. So it's really designed to kind of be a peer and a helper in that space. From a pure subnet utilization perspective, I want to make sure you're aware of this subnet utilization feature that went GA, I believe, a month ago. And what this feature does is if you use the get subnet command and you put the flag view with utilization, it will show you the utilization of your IPv4 and your IPv6 addresses. We did integrate this into the UI, so if you go to a subnet details page, you can see this kind of utilization field here. But one of the things we also wanted to implement to be more proactive about potentially running into IP exhaustion issues is integrate with different surface areas. So one of the first ones we integrated with was if you're creating a new VM, and if you pick a subnet that has high utilization and we don't think it's going to be enough for you to have future growth, we'll throw a warning there and say, hey, choose another one. So the idea there is that we want to prevent you from getting into, I guess, sticky situations in the future and help you up front. So from there, I do want to highlight some helpful documentation. We have several blog posts that have come out over the course of, I guess, late last year, early this year. There's the blog post talking about the multi-subnet feature. There is a blog post talking about auto IPAM, which Ivy mentioned. There's another blog post for leveraging Class E. So I highly recommend looking those up if you want to learn even more about those features. And then one that I'm probably a little impartial to because this was something that I work with someone else on the team, but I think it's a really cool artifact that gives you all things GKE IPAM in one place. So it talks about a lot of what we discussed today. It'll talk about our flat network model. It'll talk about some of those challenges. It'll tell you how to navigate them, whether you're in the V4 or V6 world. And just a great kind of asset to have on hand if you need something to reference after this talk. So with that, that is the conclusion of what we have today. And I would love to see if there are any questions in the room and answer and help you out. Are there mics or just, okay. Okay.
So, just wondering, like,
So this is largely applicable to GKE, but some of these features are available in the OSS. So like the flexible service CIDR, that is an open source feature that you can also use with non-GKE clusters. Good.
So two things. The first one is where you mentioned the limitation with window kind of went over it very quickly. That's a serious issue.
Yeah.
We've implemented this, and if you have OLTP databases or any SQL databases that are Windows, not going to work.
Mm-hmm.
So that was one thing. I definitely wanted to know more about the subsetting with the load balancer when you do the V2 version.
Mm-hmm.
What does that include? Because we tried going that route and then the developers didn't want to do it because it involved a huge amount of changes. So I wondered if you could go a little bit deeper into it and explain what it actually does from the load balancer perspective.
Are you talking about the internal LB subsetting feature
So
that is?
your slide where you talk.
That is, well, the multi-subnet cluster does not solve, oh. Yeah, it does not solve, actually, it is compatible with the subsetting.
I think. Okay. So the additional subsetting does not solve needing to add an additional range. What it's saying is that once you add an additional range to your cluster, here's how you go and use it with these different flavors of load balancers. So that's your question, right? Like, how do you solve the IP exhaustion? And then these are the different types of load balancers that you can use it with.
Oh, so anything outside of this you can't?
Correct.
So any external load balancer you can't use?
It covers many, like external, it actually supports NAG-based external load balancings, yes. But for standalone load balancing, it is not supported. It will still work, but if the node is selected for the new subnet that we put into the cluster, for example, and then if the standalone load balancer, it may not work. But I think this covers the most commonly used, including the internal and external load balancers for both L4 and L7 layers. Mm-hmm.
Good? Okay. Oh, yeah, go ahead, sorry.
Yeah, how this is different from the overlay C9 feature?
Overlay? So when you say overlay, I assume you are mentioning like, oh my goodness, island mode? Like an island mode? Where you can share ranges across different like VPCs?
It's not from your VPC.
Okay.
It's another layer. Kind of virtual.
Are you Azure?
Yeah.
Azure. Okay, I think what you're referencing is similar to the island mode where you can share across. Actually, the paper will be super helpful for this. GKE does not support an island mode, and we likely will not. Because we believe that the out-of-box goodness that you get with the flat network model is much more beneficial for most use cases. Now, I do know that there are some side effects to that. One is really not being able to reuse those IPs, so it requires you to have a lot more IP addresses and a lot larger IP address space. One of the things that we've done is we do have these features that allow you to add more. The 2x IP pod inefficiency is going away. But what the paper is really helpful about is that if you want to use a version of an overlay, what you can do is you can kind of emulate it and recreate it within the construct of GKE's flat network. And the paper shows you how to do that by leveraging like different GCP technologies. So that's kind of our answer to that one. Yeah, no problem. Thank you.
Thank you.